Back in 2012, I went to Israel to see the Better Place battery swapping experience. It was a company that tried, back in 2012, to revolutionize the way we thought about electric vehicles. It wanted to do away with charging stations for the most part and have people drive cars with battery packs that could be easily swapped at one of many different battery swap stations. Unfortunately, that company folded fairly soon after my visit. But these days, battery swapping is coming back in a big way. There are battery swapping stations in China and in Europe that are operated by Chinese automakers. And here in San Francisco, I'm at the headquarters of Ample, which aims to change the way we think about battery swapping. Gone are the days of specific battery pack options for specific vehicles, and in its place, a more modular, more adaptable solution. I'm here with Khaled Hassouna, who is the CEO and co-founder of Ample. We're going to be talking about how Ample is different from the battery swap solutions that came before, what the commercial applications of it are, and how important it is in a rapidly changing EV world. Khaled, thank you so much for joining me.
It's a pleasure.
Ample is very different to every other battery swap company that's come before. Tell us a little bit about what makes Ample different.
I think we approach the problem in a fundamentally different way. Instead of trying to say that we're trying to find an incremental improvement, we wanted from day one to think about the problem in a way where it can be immediately faster, cheaper, and more convenient than gas. And that's the fundamental way we thought about it. So we thought our stations have to be faster to deploy. We should be able to set up a whole city in a few weeks. They have to be cheaper than gas, and they have to be very convenient to the end consumer. But another aspect that was really, really important to us from the beginning was that we would be able to be future compatible with any car model. We didn't want to build a per car solution. We want to say any car on the road should be able to be swappable without making any fundamental changes to the vehicle.
And that's required that Ample works much more on the software engineering side and much more with a one-size-fits-all hardware solution that can be adapted to every vehicle. Now, previously, we saw battery swap solutions that required working in line with OEMs at the point the vehicle was produced to make sure that the battery pack was a specific dimension and was compatible with a battery swap solution. What you're essentially doing is designing retrofit battery trays that your modules can then fit inside. So talk me through that process.
Right. I mean, generally, we don't think of it as a retrofit because our goal is not to take existing cars, take batteries out, put new systems in, but effectively to make it as in a drop-in replacement. So at the factory, you would choose whether you have a fixed battery system or a swappable battery system. And in a way that's not foreign to how autos are built today. Today, you can go on a website and pick your trim and pick which sound system you want in the car and even what size battery you want, and a different system is installed. But we've built it so that we separate the integration into the vehicle from the module itself. There's one module that works across different vehicles, and how it's arranged, how many of them are put in a vehicle, and in what formation is specific to that vehicle given the space available and the size available. What that means is that now we can build one component as specific to each vehicle that is a drop-in replacement of the original battery, but still able to use one battery across all modules, which means we can create effectively the gas station of electric where we can deliver the same kind of energy across multiple vehicles.
Sticking with the battery pack for a second, I don't know how much of the technical specifications you're happy to go into, but what type of batteries are you using?
I mean, that's a beauty of the system, which is two things. One of them is once you build a slightly bigger module that's not too big, you can fit in different vehicles, you can arrange it, but you have a lot of flexibility in what you put inside that module. So initially we started, I'll share some information, it's typically not publicly available. We started with using 18650 cells, and now we switched to 21700 cells. We have that flexibility. We can continuously adapt to the technology you're actually putting inside the modules. But the modules themselves continue to be the same, which means you can continue updating the technology you're making available to the vehicles, hence allowing the same cars to go further and further over time by either changing the chemistry or putting different form factor of the cells inside them.
And that's a really exciting prospect for a lot of EV owners, because right now there's a lot of bad news surrounding pouch cells. Pouch cells are considered subpar. We've had issues of cars catching fire with pouch cells. Obviously, LG Energy is in particularly hot water right now through its pouch cells, and giving customers the option to essentially use a superior form factor technology is going to be a great boon both for you as an operator, but also for the customer. We know that cylindrical cells tend to suffer less from premature battery aging. It's much easier to keep a cooler thermal spread throughout the battery pack and to have better thermal management. So is that something that you think is going to be a bonus for fleet operators who are looking to go electric? Or is that just an added bonus for you guys?
100%. I mean, I think what we did when we started convincing the whole world that they should go electric is that we said, listen, we're going to sell you a car that's more expensive, that 30% of the cost is in this device that is can go bad very easily. And I think the fundamental problem with that is that we're penalizing the early adopters. We're penalizing the people who are buying an early battery that we know is going to be a lot worse than the batteries are going to come later. And if we can take that out of the equation and say, listen, as long as battery gets better, you're going to keep being able to make use of newer and newer chemistries and better batteries, we take that stigma out of it. But another aspect of it is that you can, one of the things we're trying to accomplish is to be environmentally friendly by not having to recycle or discard equipment too soon. And if a car can survive for 15 years, we should be able to use it 15 years as opposed to discard it because the battery went bad and it's too bad, it's too expensive to replace it. It's not just better for the fleets and for us, it's better for the OEMs. Because to your example about GM, the OEMs are in a very tough position where we have to make future decisions about battery chemistry years in advance, and they're stuck with it because it's hard to replace it. And we make it very easy for them to continuously adopt newer technology in a lot simpler way.
And because you're using a common module design that you're then replicating in different capacities for different vehicle packs, I'm assuming it's easier from a production point of view and also an ROI point of view. You're having a lower capex because you're producing a uniform module across all the batteries. You're producing these modules that can be easily switched out. If one module dies in a pack, you don't have to replace the entire pack. You could just replace the module. I'm assuming that you are doing BMS at the module level and cell level rather than at the pack level.
You understand us very well.
I'm guessing you have done some cost analysis on the difference between running a modular system where you can replace modules as required versus a pack-based system, and also the benefits of actually having cell by cell and module by module battery management system rather than a whole pack management.
Absolutely. At the end, it invariably gets a lot cheaper for everyone across a few different dimensions. One of them is what you mentioned, which is scale. The more you build of something, the less expensive it becomes, the more you can use economies of scale, and the more uniform it is, the more true that is. And I think the way we like to describe what we've done is that we standardize the battery without forcing the OEMs to standardize their pack. They still build the vehicles the way that's optimal for them, for the market they're targeting, for what features they want to introduce, but still we're able to use one module across and scale it up very quickly across a larger number of vehicles. And that allows us to bring the economics down very, very, very quickly. But another thing is exactly what you described, which is right now, if there is a recall, for example, it's really expensive, right? You literally have to bring every car in a shop, have a technician work on it for hours to take it out and put another one in. In our case, if we have one battery that's bad, the next time it swaps, we just put it aside and don't swap in the next car.
Right.
So it's a lot simpler, a lot easier, and that means that everything becomes a lot simpler. Maintenance, installation, support, second life of the battery. Literally, it's plugged in a wall, now we plug in a different wall, reuse it. So ability to kind of scale up the use of the system, not just kind of the number that you're producing, is another way to reduce the cost for everybody very quickly.
One of the things that Ample has really worked hard to focus on is the fact that its battery swap stations are very different to previous battery swap stations we've seen, where you required subterranean digging, you required to have a massive amount of machinery underground to provide the battery swap experience. It's how Better Place had its stations. But what we've got here is a representation of what an Ample swap station would be if it was, you know, in New York City, in London, wherever. How does this compare to a system where you drive on and drive out?
I think first it's a lot cheaper, a lot faster to deploy. But also, as we scale up, it's going to be very hard to find places to create the infrastructure for electric, be it charging or any other solution. And I think the simplification of being able to say, all we need is 2 parking spots that are flat, and then we can set up a station in 1 week, means we open up a lot of options. And we can deploy them in more places faster, but also our threshold for what would be a good location for us to put a station just goes down, because if after 2 years it's not the right place, we can literally just turn it down, build it up to 2 blocks away, and then we have it there.
I'm guessing it also means you can rent rather than buy land. So
Correct.
you can rent from a landlord as long as you've got an appropriate power source.
Correct.
You can put a battery in. Are you looking at installing Ample swap stations in places that don't have grid power, maybe using an off-grid battery backup system?
We can, if you're on a highway between cities, we can literally build the solar panels next to the station and have not even need a grid connection. But even within cities where we install, I think a big part of the challenge, for example, if you're installing 6 250 kilowatt stations, you really need 1.5 megawatt feeds. There are very few places in larger cities where we actually want to move to electric where that exists, or cheap or accessible. And in our case, because we're separating recharging the batteries from refueling the car, we still can get the energy in the car in 5 minutes, but we can charge the battery slowly over time. Our power requirements is a lot lower. And the limitation in city usually is not about the amount of energy you can deliver. We can deliver enough energy to power all of our cars, the amount of power that's available to you. And by lowering that requirements, we can fundamentally increase the number of places that we can install these stations, but also reduce the cost of creating that infrastructure in a very significant way.
When discussing battery swapping, the thing that comes to mind now is 800-volt cars are coming. We're seeing some 800-volt cars already on the market. The Porsche Taycan is a good example. Kia and Hyundai are both working on a high-voltage 800-volt architecture. We've seen other automakers doing the same thing. These cars are promising 80% rapid charging in under 20 minutes. We're talking 10 or 15 minutes, adding more than 100 miles, 160 kilometers of range. At that point, what part does a battery swap station have, other than the infrastructure requirements that you already detailed, when you can just plug in and recharge? So how do you market that to people who are saying, well, I can just keep my battery? We humans like to own things rather than to lease things.
Right. I mean, I think, so those are 2 big areas. Let me cover each one of them. Own versus lease. I think the world is moving in a very different direction. I think we're moving in a direction in which we're trying to limit our use of resources, and we can't justify paying 100% of something I'm using 5% of the time. And hence, it makes perfect sense as we have more humans on Earth is to actually start becoming smarter. And as our technology is there, phones, internet, cloud, to actually start becoming a lot smarter about how we use our resources. So the ability to share resources is a lot more consistent with the trend in which we are all going and how we are starting to live our lives already every day than otherwise. So I think that kind of is more a favor in more in direction of in favor of an Ample or a battery swapping solution. The other big component to it is that we're not just saying you're not going to own your battery. We're saying you don't even need to worry about the complexity and the cost of doing that, because we always make sure you have a battery as good as new. Now, the other aspect is the question about fast charging. So we're supportive of charging. We think we should install as many chargers as possibly can, right? Just because the problem is so massive of moving a third of human consumption of energy, which is transportation, from fossil fuels to electric. So we don't have the luxury of saying, oh, it's this solution or that solution. We need all solutions. That said, when it comes to very rapid charging, I think there is a lot of fundamental challenges that are going to be very, very difficult, right? We're having a hard time installing 250 to 350 kilowatt charging right now. If you think about a place like San Francisco, they're almost nowhere to be found. And we are one of the top tech cities in the world. And the reason is because first, grids are going to have a hard time supporting massive demands of energy or power that comes up and down very quickly. And second, because the cost of installing them is very, very high. Now, the challenge is that we have a battery. If there's one constant about an electric car battery, it is that its capacity is going to increase. Because there's a lot of smart people thinking very hard about that problem. And the challenge you have is that if you can have a battery that can be charged in half an hour, if it's twice as dense, it's going to take an hour. So every time you bring that down, you're going to have a better battery, and you're going to want to charge it faster, and the time is going to keep increasing. The power of swapping is that if you have a battery that is twice as dense, you still deliver energy exactly the same time, which means you get twice the speed. And so it's a lot more competitive where we're going. It's always going to be nice to the grid, where it's going to get energy when it's most available. And you don't have the need to continuously rebuild all of your infrastructure. I'll make that last point, which is, if we build a lot of 350 kilowatt chargers, and now suddenly the standard is 500 kilowatt, we're not going to go rip out all the 350 and build 500. We don't have to keep rebuilding all the infrastructure again and again. That gain of speed comes for free with swapping exactly the same stations, nothing changes.
Because as the battery density increases, the energy that you can put in with a swap, you can swap a high capacity battery in the same amount of time as you can swap a low capacity.
It's always going to take me the same amount of time to move this object from here to here, regardless of how much energy it holds.
Which brings me to a question that myself and the team have been kind of talking about a lot on our drive down here from Portland. I envisage a future where we're starting to see it now. Different battery chemistries are being offered for different applications. So in China, we are now seeing, and now in the US, we're seeing Model 3s, the entry-level Tesla Model 3s coming with LFP batteries, which are less energy dense, but they require a more ethical supply chain in order to produce. They are known for having a better lifespan. They can't produce as much instantaneous power, but on the grand scheme of things, they're actually better for entry-level models. And then we've got the super high power, super energy dense lithium-ion batteries, which might be less chemically stable, but they allow you to do the stoplight sprint in 3 seconds, and they give you incredible performance and incredible rapid charging. Under Ample's system, do you see a future where, your everyday car driver has an LFP battery that they use for around town? They maybe don't bother swapping it out because they have access to a charger at work, or maybe they swap it out once a week if they live somewhere like San Francisco and they have on-street parking and no charging. And then when they do a road trip at the weekend, pull into an Ample swap station and be able to pick that more energy dense, more expensive, longer range pack that they need for that family trip to Las Vegas at the weekend. Is that something that you've got in your roadmap?
Absolutely. I mean, one of the things we focused on initially is to say, if you're going to get one battery module that works across cars or different vehicles, you are going to need to abstract the chemistry in it from the vehicle. And what that means that once you plug in that battery into a vehicle, it adapts to match what the car expects to see. And the challenge with these different chemistries is that they operate at different voltage ranges. And hence, what that means is that for the same vehicle, you're not going to be able to just easily swap one chemistry for the other. And being able to solve that problem meant that we can do a few things. You can choose a different chemistry based on the current use case, which might change day after day. To what you described, one day I might want to take a long trip. I want to drive up to Tahoe where I know I'm going to go uphill and I want a lot of power, or I might be just going to the beach for a day and then I know my car is going to be parked. So the ability to kind of choose the product that works for you based on what is it going to do at any moment in time, or even based on whether you are commuting a lot right now and later you don't, and hence you want to pay less for a battery. All of these variables allow you to just adjusting the product you want to use based on your use case. Another factor is that you can put more or less battery in the car as well, and we have that flexibility. So giving optionality to the user means we, in a whole, we'll be able to reduce the total amount of battery that's in the system and hopefully become a lot more environmentally friendly that way as well.
A lot of companies around the world are turning their fleet electric. We get an email almost every hour now from one corporation or another that has made a commitment to going electric, whether it is Uber wanting to take its fleet electric, whether it is a delivery company wanting to go electric, whether it is a mom and pop shop, in downtown New York that has a small fleet of 10 vehicles and they've decided to go electric. Lots of people are wanting to switch. But the problem is, and I didn't realize this until I owned my own business, that most small to medium businesses either lease or own property. But most large businesses lease property, and that means you have to deal with a landlord. And when you've got a large fleet, whether it's an emergency service fleet, whether it's a delivery fleet, you have to liaise with your landlord over what parking is available and what amenities are available to the parking structure. Obviously, that means if you're putting electric vehicle charging infrastructure in, you not only have to ask the landlord, you have to work with the city council, and you may have rush demand charges if you want to have a rapid charging solution at your depot. I'm assuming that your target markets are cities where there are higher numbers of leased properties in downtown areas, where it's difficult for many fleet operators to go electric because of the prohibitions and technicalities imposed on them by building landowners.
That's absolutely right. I mean, you outlined it very well in the sense of the challenge often in going electric for especially large fleets where we'll be able to make the biggest difference is not will they be okay driving an electric car. It's going to be, can they create enough infrastructure to support their operation as they do that? And everything you outlined is perfectly right. So let me build on that and say, right now the current model is that you don't think much about the infrastructure when you buy a gas car. You just buy a gas car and then you know that there is enough infrastructure around you where you can stop anywhere in the city, get a full refuel in a few minutes, and that's not going to affect you the way you run your operations. Neither do you have to worry about the cost of creating that infrastructure. And I think what's happening with electric is that's stopping to be true. And our goal is to move it back to that model, to say as a fleet, later as a consumer hopefully, and as a small business, you are not going to have to worry about that because Ample acts more as an electric gas station that is available in enough abundance that effectively you just buy the car. That's really the whole expense. And to a great degree, you don't even have to pay for the battery up front, and that's a big part of the economic incentive. But even without that, it's a huge improvement in their ability to move to electric by being able to think that I can buy an electric car just like I buy a gas car. I just make the buy decision and immediately can operate.
What are the capex differences for a fleet operator when you're offering to give them a swapping solution? Obviously, you would be putting down the infrastructure, you'll be building the swap station rather than the operator. And I'm guessing also because you're offering a service that is a business deductible rather than a depreciating asset, which infrastructure in a building would be. What happens when a company reaches out to you and says, hey, we want to work with you and do a battery swap solution?
We want it to work exactly like gas. You don't have to pay capex up front to build your infrastructure. You don't have to worry about depreciation. You don't have to worry about, do I have the land long enough for me to be able to realize the value out of it? It's $0 up front to them. All they do is just buy the cars and pay us for the miles driven. And we always aim for our cost to be at least 20% cheaper than gas. They immediately and hopefully more going forward. The reason we're able to do that is because our swapping stations are considerably cheaper to build, they're easier to install, and hence we can incorporate and include them into the overall cost. So we can immediately offer $0 upfront cost plus kind of an operational cost that's better than gas. So our goal would be not just that we can somehow make electric work. We want it to be a no-brainer that it's going to be cheaper and better. Why would I not do it?
How long does a battery swap take?
A battery, right now we're in the 10-minute range. We're moving very quickly towards 5. We have very brilliant idea to give even beyond that. So the goal would be that this would be just like filling a gas tank.
So the 60-minute charge session I had last night, because I wanted to get all the way up, would have been a lot quicker with a battery swap
Absolutely
solution.
Correct. And you would have gotten 100% charge.
Khaled, thank you very much for inviting us down and showing us around. And thanks to you guys for making this trip possible, because if it wasn't for you, we wouldn't be able to come down. Don't forget to leave your thoughts as well, and you can also do that through our Discord chat room. If you haven't already, please make sure that you have subscribed to this channel and to our other channel, Transport Evolved Take 2. We are going to be producing more content on Take 2 in the future. Thanks on behalf of the entire TE crew go out to the folks on my right for being our $15 to $49 a month Patreon supporters. Special thanks to our $50 a month patrons. They are Joseph Broucher, David Janakula, Andrew Martin, Guido Drahota, Brophy Wolf, Michael Goad, Tazla in the Gong, Sean Ueda, Gordon C, Regine Fellows, Anonymous Freak, Jim Burness, Carl Hodgson, Anthony Coates, Ricky Leon, Brian Newton, Laura Sandborn, Rory Litwin, and Denny Hyde. And our deepest gratitude goes to our $100 a month Patreon supporters: John Lyons, Marcel Ward, Reggie Watch, Joe Brenzi, JP Fagerback, Will Graylan, Matthew Drobnak, Christopher Lee Jones, Paul Conway, Ellery Hennesley, and Ian. If you're feeling left out, don't forget you can link the Patreon button below to support us. We would really appreciate it, because we are just about to hire our new, brand spanking new video editor, and he does kind of need to eat. And don't forget you can also support the channel by buying some swag from our TE store, like the Pride TE shirt that I am wearing right now. And of course, you can also support us through Ko-fi, or if you're feeling tech savvy, Bitcoin. Thanks for joining us, and as always, keep evolving.